8, we start with some new vocabulary, relations and functions. We'll start with an example. Alligators. The table below shows the ages and lengths of 5 alligators. You can represent the relationship between age and length using the ordered pair X and Y. Their age here is represented by X, the length is Y. So we can do those as an ordered pair for graphing. So the first pair would be 2, 32, coming from 2 and 32, 4, 59, 5, 65, 5, 69, and 7, 96. Here are the lists listed as coordinate points on a graph. The ordered pairs form a relation. A relation is a pairing of numbers in one set, called the domain, with the numbers in another set, called the range. Each number in the domain is an input. Each number in the range is an output. For a relation represented by ordered pairs, the inputs are the x coordinates and the outputs are the y coordinates. That's a lot of words. Let's put that into action. So first of all, I copied and pasted that table from the first slide there. And this is example 1, identifying the domain and range. So the questions are, first, identify the domain and range of the relation represented by the table above, and then identify the domain and range of the relation represented by the table below. The new table, the one below, shows one alligator's length at different ages. So if I look at the top table here, again, the domain are the x's, and the range are the y's. So the domain for the first table would be 2, 4, 5, and 7. Notice that I only wrote the 5 once. Also, the numbers should be listed in numerical order. In the chart, they are already arranged in numerical order. So no repeating and arranged in alphabetical order. That rule is true for range as well. So the range, I list those, and again, they're nice and in numerical order already in the table. So it's 32, 59, 65, 69, and 96. So if we do that again on for letter B, for the table showing one alligator's length at different ages, we will see that that domain is 1, 2, 3, 4, 5, and that range is 23, 36, 47, 61, and 73. There are no repeating numbers in either one of those domains, so we have five domains and 5 ranges. Now, identify the domain, which is x, and the range, which is y, of these relations. What we have here are a set of, or 4 sets of coordinate points. When we're talking about coordinate points, the first point is the x value and the second point is the y value. So if I'm going to do all of the x's, would be the domain. I would have 0, 2, 3, and 5. And then if I was going to do the y's, the second coordinate point, the range would be 1, 4, and 7. Notice there's another 4, but we do not repeat, and we put them in numerical order. Doing that same thing to the set of these 4 sets of coordinate points. I look at my x's, I put them in numerical order for my domain answer. The domain there would be -3. That's the smallest number. We see that the furthest left on a number line. Then we have -1, in which we have 2 of those. We only write it once. And then we have the +6. The range, the y numbers, which are the second coordinate points, again in numerical order. -1 is the smallest one, furthest left on the number line. Then would come 0, then would come 2, then would come 4. So the two challenges you have when you have coordinate points or when they're given in a graph is to put each information into numerical order the way you see it on a number line from left to right, and then also not to put any repeats in there. It's easy to cross out the numbers when you're working on a worksheet or a quiz or a test. Representing relations, in addition to using the ordered pairs, which we used on the first screens, or a table to represent a relation, you can also use a graph or a mapping diagram. So example 2 shows us both of those. Representing the relation, and here is the relation we will use for both of these examples, 1, 3, negative 3, 4, 0, 2, and 1, negative 3. First, we'll put those points on a graph. So 1, 3, we're going to go over 1 and up 3. Again, remember our rule about reading. You read left to right, and then you work down and back up the next page. Left and right first, then down and up, down or up. So over 1, up 3 for the first one. We're at 0, 0 again, the origin, and we're going to go to the left, negative 3, and then up 4 because it's a positive. Go back to the origin again, and we're going to go 0. We're not going to move either way, left or right, and we're going to move up 2. And then for our last point, we're going to move over 1 and down a negative 3. And those are the points in the coordinate plane that is representing that relation. Now we can also use a mapping diagram in which we make a list of inputs and outputs, or our x's are the inputs and our outputs are the y's. In this activity, you would still organize your inputs in least to greatest. Again, the way that you would see them on a number line. You can use the one right here in the table to see that. So negative 3 would be first, then 0, then 1. Again, we do not do any repeats when we're doing one exercise such as this, or an example such as this, the mapping diagram. Then it says, draw arrows from the inputs to their outputs. So I'm going to go ahead and I'm going to say negative 3. Negative 3 from our coordinate points went to 4. So I'm going to go ahead and I'm going to draw my arrow to the 4. Now my next coordinate point was in my input chart is 0. Up here, 0 needs to go to 2. So I need to get another arrow, and 0 is going to go to 2. Now the next point listed is 1, and I have 2 different sets of coordinate points that have 1 as their x value or their input. So 1 would go to, in the first one, 1 would go to 3. And then also for the second coordinate point in the list, 1 could also go to a negative 3. And that is a mapping diagram of the relations. Next, we're going to talk about functions. Functions is a special type of a relation. A relation is a function if for each input, or x, there is exactly one output, or y. In this case, the output is a function. We call it a function instead of a relation. So it says, first of all, for example 3, tell whether the relation is a function. So we look at what our inputs are. I'll put those in order. 2, 4, 5, and 7. Okay, I did not repeat the 5s. Now again, to be a function, for each input, there is exactly one output. So for 2, 2 has 32, 4 has 59, 5 has 65, but it also has 69. 5 has 65 and also 69. So this is not a function. Sorry, writing with my finger again. No, this one's not a function. Now if we move down to letter B, this one had to do with the alligator at different times of his life. So his ages 1, 2, 3, 4, and 5 are our inputs. At age 1, he was 23. At age 2, he was 36 inches long. At age 3, he grew to 47. At age 4, 61 inches long, and at age 5, 73. There was no point from age 1 through 5 where the alligator did not grow, so there are no two outputs for one input. So this would be a function. None of the inputs share or have more than one output.